Hey, what's going on, guys? It's the kid that cares about his eye health, and today I'm coming at you with another C++ tutorial. So today is going to be a bit of a lengthy one. I have a goal set for myself right now to keep it under 20 minutes. Hopefully. We got a lot of stuff to cover though. We're going to be going over some inputting and variables, all right? And then printing those variables. And then maybe some basic math operators that we can do on those variables. So just like before, we're going to get started with a new replit. We could use our previous program, but we're just going to make a new one just for this. We're going to call it second video. You could call it whatever you want, though. You don't have to call it second video. Maybe call it variables and inputting, something a little bit more descriptive than I would call it. All right, so we're back in a familiar landscape. We see that we have our cout statement. We're going to go ahead and delete that, and let's just jump into some variables. So what are variables? Well, it's essentially a thing that can save some data depending on what type it is, and yeah, so best way to explain this is what types of variables do we have? Okay, well, we have something like an int, we have doubles, and we have strings. Strings are a bit weird, so we're going to get to that one last, but the general scheme of how this works is you type the type of variable that you want, a name for the variable, set it equal to some value, and then close that off. All right, so if we want to do that with an integer, and this is just any whole number, basically all the negative numbers, all the positive numbers, and 0, but it has to be a whole number, so nothing that has decimal places. So for our example, we could say int, and we'll call this age, and we'll set that equal to 5, all right? And then if we go ahead, we can use a cout statement here, and we could print the variable. Okay. So if we go ahead and print it, we can see, and this is set up just the same way that we did before when we're printing out stuff. We just use the variable name instead of some quotation marks. Okay. And then as we can see here, it prints out 5, which is just what we wanted because we set age equal to 5. All right, cool. So that makes sense. But hey, Ben, I want to write some decimals. All right, well, I have just the trick for you. If you want to write variable or use decimal point numbers, you can use something as a float or a double. To make a long story short, basically a long time ago when programming languages were being conceived, we only had float. And then at some point we were like, yo, we need some more precision here. We need to get more decimal places because float can only hold about 7 decimal places before it starts cutting off numbers or kind of messing them up and not giving us what we want to. And I'll show you a great example in a second. So what a double is it basically takes double the memory, but it also holds about 18 to 20-ish, give or take, decimal places with good precision, right? Because since all this, just a little bit more stuff about what's going on in the background, binary doesn't have a great way of saving decimal places, or it kind of struggles as the numbers get a lot bigger, but it does great with just regular integers. Okay, so that was your quick history lesson there, but just keep in mind that double does take double the memory as a float. Okay, and you don't need to worry about any memory constraints now. We are working with really small programs here, so don't get yourself flustered over memory. That was something that I did, and that's really something silly to worry about because, worry about that when you want to get a job. We'll keep it at that. So if we want a double, well, let's do pi, for example. All right, now this is obviously not actual pi, but it's my close approximation, to say the least. Okay, so if we have something like this, and then we go ahead and try to print out pi, well, as we can see, hey, wait a second. We only have 5 decimal places here? Well, what's going on with that? Well, this actually introduces a whole new thing. So for some reason, cout is set to a default of only printing out 5 decimal places. But luckily for us, there's a command that we could use to lengthen that. Okay, so we're going to do #include. So we're including a new library, and this is going to be called iomanip. All right, and you could just think of this as input-output manipulation. We're changing something in the way that we are inputting values and changing something about the way we're outputting values. Or we could anyway with this library. So what we can do is we type another cout statement, except this time it's set up a little bit differently. Rather than printing out anything, we are essentially giving a command as to how we want to print stuff out. Okay, so in this example, we can do std, or we're going to use this cool function here, and it's std : set precision. And this just says, hey, how many decimal places do you want to go out to? And we'll say 16 to start, okay? And what this is going to do is every cout statement that is under this one is going to print out 16 decimal places if there even are that many, okay? If not, it still prints it out if there's only 15, 14, etc., etc. Okay, so if we go ahead and try printing this now, hey, look at that. Looks pretty good. Okay, so I think now is a perfect time to bring up the problem with float. If you would even call it that, more like just a kind of weird nuance to float, okay? So we'll call this fpot. And take note with how I'm doing lowercase for the first word and then uppercase for the second word. This is a pretty regular naming convention. I believe it's called camel case. Don't quote me on that. And that's just where you, for variables anyway, you start with a lowercase word, and then as soon as you hit the next word, you start capitalizing, because you can't use spaces in variable names. Also should be noted, you cannot start a variable name with a number, but if you were inside the variable name, like at the end, you could put a number at the end. It just cannot start with a number or a space, okay? So let's go ahead and see what happens when we print out these two variables, okay? So we're going to print out the float pi first, and then we're going to print out the double pi. So if we go ahead and run this, float pi, and I guess it would also help if we threw an endl in, all right? I probably should have watched the first tutorial another time. Okay, so up top we have the floating point, and down the bottom we have double. Well, as we can see, after the first 7 decimal places, floating point goes in an entirely different direction as to how we told it to save the number, right? Up here, we're declaring both of these variables, right? And that's just when you make a sentence that looks like this, or make a line of code that looks like this. This just means you're declaring a variable. We're declaring them to be both equal to the same thing, but floating point after 7 digits, or after 7 decimal places, starts to have problems understanding what else was saved to it, okay? So just keep that in mind if you're working with really big decimal places like pi, or maybe Euler's number, or some mathematical number, to be wary of what you're saving it to. Double does a lot better job of it because it's double the space, as we said. All right, cool. So we see the problems of using that, and then just something to mention with this set precision, okay? So if we wanted to, or if we need to, we could go ahead and set the precision back down to 5. And then if we go ahead and try and print these again, okay, throw some more and lies, okay. And then if we print these again, we could see after we change the precision, it goes back down to 5 decimal places, okay. So just something to know there. All right, just got a little Windows notification. Don't mind that. Alrighty, cool. So hopefully this gets the point across with just using int, float, and double, the problems of them, and some stuff like that. So we're going to go ahead and erase all this. You could keep it on your page. You could comment it out. I guess it should also be important to note what a comment is. Basically, it's just a little bit of wording that you could throw into your code to sort of help someone understand your code, or even help you remember what you were writing about, okay? So maybe down here we could say, hey, this part prints something, or something like that. You know, you could just say something, and then maybe you could start writing your cout statement, okay? You could do something like that. But, yeah, we're not going to worry about variables too much, but you could use them in your code as you please. Simple two backslashes, or you could do something like this, backslash asterisk, and then an asterisk backslash. Jeez, that's hard for my mouth to put out. And then you could basically make it on multiple lines where you want to type. So if you maybe on the top of your program that you're writing, you want to give like a little introduction to yourself, or maybe like even put like your name or something if you're like handing in, whatever you want to do. But just gives you a little couple options here. All right, so let's talk about strings. So string is another weird little nuance about strings is there needs to be another library in order to use strings. So for this, we would use hashtag include string. So string is just another library, and we need to do this in order to use strings, right? And string has to be prefixed with the std, and then same way, so that's our type, so we need a name for it. We'll call it name because it's going to be our name, and I'm just going to save it as Benjamin Lloyd because that's my name. Okay. And then down here, we could go ahead and print it out. Okay. And we could say name, bam, just like that. And if we run this, we could see it prints our name, just as normal. Cool. So with that being said, we understand the basics of variables. We know how to set them up here. But what happens if we want the user to set up, like give the user the chance to set up variables? Okay. Well, what we could do for that is, luckily for us, we already have IOStream here. Like I said in the first episode, this deals with inputting, but also outputting, okay? So we've only been taking advantage of cout, but luckily for us, there's also a cin function. So when you're asking for input, it's a really good idea to first print what is the user even inputting, right? So the user needs to understand what they need to type first, before you actually get something in. Now, I'm not saying you have to, like the code's not going to work if you don't do this, but for our example here, it would make a lot more sense to tell the user, hey, we need you to input a word, so they don't put numbers in, for example, right? So then we could cin name. So just like before, except this time the chevrons are reversed, so they're greater than, and then the variable we want to save the information to. And then down here, we're going to go ahead and print our name again. Or your name is name. Okay, so also notice we did not put an end L here. We don't need to worry about a end line because cin will take care of that for us. Okay, so let's go ahead and try to run this, and let's see. Enter a word. Well, I'm just going to go ahead and enter my name. Okay, and what do you know? Your name is Benjamin. Cool. Now, you know what? I want to make it my full name, Benjamin Lloyd. Okay. Well, oh, my name's Benjamin. No, it's Benjamin Lloyd. Oh, okay. Well, this brings up an interesting problem. So the thing about cin is, as soon as it encounters a space, it decides, okay, I don't need anything else. We don't throw it away though. It's still saved somewhere. It's kind of in this buffer zone. So if you've ever played a game like Sims, or maybe something similar to it, where you tell your character to do something, and then you could tell them to do something else. Well, they have to finish the first thing they're doing before they go to do something else. So similar to this, we're telling it to save our name as Benjamin, but then this is kind of getting saved somewhere to be used later. Okay, so there's two ways to go about this. I'm going to show you the wrong way to do this first. All right, so let's say we do one for string last name, and we're going to amend this to be string f name. Okay, so we're going to say we're going to get the f name first, and then we'll go ahead and do another cin right after that to get the last name. Okay, and then we're going to change our print statement a little bit, and we'll say your name is f name plus, notice how we don't have to do, we don't have to use chevrons here, okay? Now this is going to put the two words right next to each other. There's not going to be a space in between it. But for our example, I don't think we have to worry about that too much. So enter a word. We're going to say Benjamin Lloyd. And what do you know? Your name is Benjamin Lloyd. So this cin got Benjamin, okay? And then this cin down here got Lloyd. All right, cool. Now this is a bad way to do this, because say you have a 20-word sentence you want someone to input. Well, then you're going to need 20 of these in order to do it this way. Now there's a lot better way to do this, and that is using another function called getLine. And that's actually all lower cases to do it. Okay, so when you type in getLine, in Replit at least, there's going to be this crazy complicated stuff that needs pointers and what are these asterisks? You know, hey, let's just not worry about that for right now. What we need to write is stdcin, right? So the function we're going to call in order to get information in, and then the name we want to save it to, or the variable we want to save it to. Okay, so kind of just disregard the autofill-in information here, or that they show you for getLine. Okay, and let's just look at it like this. So we could take that out, and if we do it like this, and we go ahead and type in Benjamin Lloyd, we can see it does just that. It gets the entire line that we entered, even with the space. Cool. So that's kind of the two different ways. This is a lot more useful for when you're asking people to input a sentence. If you're only asking someone to input their first name, then I would say it's completely fine to just use cin once, right? But we're looking at sentences here to input. All right, cool. So we've gone over this. And the thing about cin is it works exactly the same way with number variables. Okay. So if we, for example, wanted to input your age, got to tell the computer, or tell the user that we want him to enter his age. Enter your age. Okay. We'll say your age is age. Okay. And if we go ahead and run this, it's going to ask us for our age. 5, and your age is 5. Cool. What happens if we try writing a string though? Let's say, oh, 5. Well, your age is 0. So just keep this in mind when you're asking input. Input is really picky about what you are actually inputting. So make sure, there's other ways where you can check to make sure that something was inputted right. We're not going to do that. We don't need to worry about validating input. But this is just a quick little point to make, that you have to actually worry about what type the variable is when you're asking for input. Okay. So, final thing we are going to do for today is math operators. So, in order to set up for this, I want to make 2 int variables. We're going to say summand1 and int summand2. So we're going to initialize 2 variables here. They don't have any value set to them right now, so they're just initialized. Okay, and then if we go ahead and we're going to ask the user to input some numbers. Okay, so we're going to say enter a number, or we could even say enter first number, but we're not going to get too picky about this. All right, too specific. Okay, enter a number, and then we're going to do cin, and we're going to save that to summand1, and that's a fancy math word for just showing the two numbers that you're going to add together. Okay. And then we could say enter a second number. Okay, we'll save this to summand2. And then now we want to do some math on this. Well, there's a couple ways we could go about this. So we can just do cout, and we could just type out summand1 plus summand2, right? So if we do this, it's just going to print out the sum, all right? So it's just going to add those 2 variables together. So say we do 5 and 10, it prints 15. Okay, makes sense. Now, if you're doing something like this, this doesn't save the answer of 15 anywhere. And that might be something you want to do. You might be constantly using the sum of something. So it might make more sense to make another variable, call it sum, and have it equal to these 2 things here, right? Whatever we're adding together. So we can see out the sum instead, and let's not forget a semicolon at the end. And if we go ahead and do this now, we have 5, we have 19, we get 24, and we printed it out nearly the same way as before. Okay, and this pretty much extends to all other math operators. I mean, if you wanted to, you could do division, you could do multiplication, you could do subtraction, and you could do this really weird thing that I've only seen in like a handful of math classes. I think I've seen it in like one math class, but it's used a lot in programming, and it's this modulus function. And it's really similar to division, except rather than giving you the amount of times that the number goes into another number, so if you did 15 divided by 3, you would get out 5. The modulus, though, would give you 0, okay? Because 3 goes into 15 5 times. Let's say you did 15 divided by 4. Well, let's go ahead and do that because I don't know that off the top of my head. I mean, I should, but I don't. All right? So we're going to enter 15 and 4, and look at that. We get 3. So what did this do? Well, it's basically giving you the remainder of your division, if there even is one. I mean, sure, this could also give you 0. There's nothing wrong with that. So you could say 15 and 3, and you would get 0, right? Because there's no remainder between those two. So that's basically what the modulus function does. So at this point, that is pretty much it for this lesson. If you need to, just go back, rewatch stuff. A lot of the times, wherever we use string, you could also use integers to get the same point across. Or they're pretty much interchangeable. With cin, you could see in numbers, you could see in strings, you could see in doubles, you could see in all sorts of stuff. I guess just if it helps, you could also see, if you try inputting a number that has decimal places, but you're saving it to an integer. Okay, this will be the last point that I make, and then we'll call this a video. Choose my changes. Okay, right here was a great example of sometimes what happens with Replit. Sometimes it can't connect to the server properly. Okay, so if we say we want to input a number and we're saving this to an integer variable type, well, let's say we do 2.92 blah 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 blah. All it gets is 2. So just remember, when you're inputting stuff with int, it cuts off the variables. It does not round the variables. Okay, so that's where we're going to call it a video. Hopefully you guys enjoyed. I'm not going to put a project for this one because hopefully I'll have the next video out soon, and then that one we will do a cute little project for that. All right, so cool beans. Hopefully you guys enjoyed, and I'll catch you in the next one.